let's get after our next one. And this is a little different of a scenario. So, do you remember talking about the degree of a polynomial? A degree? So let's look at this fun-filled one right here. Okay, so we have x cubed plus x. So our degree up top, this is degree 3. And then down below, we have a degree 1. Well, if this is going to end up happening, well, we're not going to use PFDs in the normal way. Sorry, y'all, but we need to think about something called long division. So we have our function, or what we call our integrand. Well, that's a division. And since we have a larger degree up top than we do down below, that means we could do some division. So we have a linear function down below. So how would you want to do this? Would you want to set it up as such, x minus 1? The top always goes in the house. There's no x squareds. There's 1x, and then there's absolutely nothing at the end. Would you do it this way? You can do it that way. Or would you do it this way, where you use synthetic division, where, see, we have a 1 as the coefficient on our x cubed. We have a 0 on the x squared. You got to make sure to put all those terms in. We have a 1 on the x, and we have a 0 on the number. And if it goes in cleanly, we should end up with a 0 right here. It's not going to go in cleanly. So let's see what we got. See if we remember how to do this. So you drop the 1 to the bottom, and now we multiply. 1 times 1 is 1. Now we add. 0 plus 1 is 1. Now we multiply again, and we get 1. Now 1 times 1 is, or 1 plus 1 is 2. And then we do 1 times 2, which is 2. So we end up with a 2 at the end. Now what does this turn out to be? Well, this is your constant, the 2. Here's your x, and here's your x squared. So it turns out that this is equal to x squared plus x plus 2, and then we have this last part here, which is saying that we're going to divide by the x minus 1. So I didn't show the long division because I assume most of us know how to do that. But whenever you have a linear factor in the bottom, synthetic is just, I don't know, it's just quicker. Seems to be less mistakes. So now we have x squared plus x plus 2 plus 2 over x minus 1 dx. And that's about as straightforward of a frickin', not as straightforward as they get. So we add 1 to our exponent and we divide by that number. We add 1 to the exponent and we divide by that number. We give this one an x. And lastly, we have 2 times 1 over, 2 times 1 over x minus 1. Well, the antiderivative of 1 over x minus 1 is just the natural log of the absolute value of x minus 1. And don't forget your plus c. And there we go. Just a little bit of synthetic division or long division. Just in case you're curious. Let's do it as actual long division. What the heck? Let's do it. So x goes into x cubed. You need to multiply by x squared. So now if you bring that in, it's x squared times x and x minus 1. So you get x cubed minus x squared. And then we're going to subtract the whole thing. So we change the signs. We add them up and we get 0x squared plus 1x squared. That's just an x squared. And we drop this down. Now we say x times what equals x squared? Well, that's clearly just an x. So now we multiply x times x minus 1 for x squared minus x. But we're going to subtract it, so we change both signs. We add them up and we get 2x. We drop our 0 down and we're like, all right, so it's 2 times x. 2 times x will give us 2x. So we get 2x minus 2. We subtract it by changing both sides. And we end up with a 2, telling us that our answer is this. A little circle, x squared plus x plus 2. And then this part just becomes the numerator over our divisor. So we'd still get to the same spot. 2 different methods to get there. But this is something that we must be good with. It will pop up pretty consistently throughout Calc 2 and Calc 3, having to do some long division. But whenever there's a linear factor, I definitely prefer to use synthetic division because it only works for linear factors. But I don't know. Check it out. Next one, we're going to bring the heat, okay? It's going to get a little bit nuttier, but nothing you can't handle.